What if I told you that the machine reading your brain right now was actually conceived in the mind of a Serbian genius over 140 years ago? Picture this. It's 1882, and while Thomas Edison is still wrestling with direct current, Nikola Tesla has a revelation that will eventually let us see thoughts dancing across neurons in real time. Wild, right? Here's the thing about Tesla that most people miss. He wasn't just inventing cool electrical tricks to wow audiences. When he discovered the rotating magnetic field, he unlocked something fundamental about how we can manipulate electromagnetic forces. Think of it like discovering you can spin a coin perfectly on a table. It sounds simple, but that spin, that rotation, that's the secret sauce that powers everything from your ceiling fan to the $3 million magnet that can photograph your memories. Now, let's connect some dots that nobody talks about. Tesla's whole genius was figuring out alternating current. Unlike Edison's direct current that flows in one boring direction, alternating current dances back and forth at high frequencies. And here's where it gets interesting for medical imaging. Those same principles of rapid oscillation that let Tesla transmit power across cities, they're the exact foundation for the high-frequency pulses that modern MRI machines use to excite hydrogen atoms in your body. It's the same physics, just aimed at different targets. But we had to shrink things down, way down. Tesla's systems were designed to light up entire neighborhoods. Medical engineers took that same concept of gradient magnetic fields and miniaturized it into these incredibly precise coils that can target specific slices of your brain without even touching you. Imagine conducting a symphony where every instrument is an electromagnetic wave, and together they create a picture of your internal organs. That's spatial encoding, baby, and it all traces back to Tesla's understanding of how alternating fields can be controlled with incredible precision. The Tesla unit of measurement? Not a coincidence. 1 Tesla equals 10,000 Gauss, and that number directly determines how clear your MRI images will be. It's literally named after him because his work on magnetic field strength laid the groundwork for understanding signal-to-noise ratios. The stronger the field, the clearer the image. Simple as that. We've gone from basic 1.5 Tesla clinical scanners to these beast mode 7 Tesla research magnets that can practically count individual brain cells. Now here's where things get absolutely mind-blowing. Functional MRI takes this even further. We're not just looking at brain structure anymore, we're watching your brain think. How? Blood flow. When neurons fire, they need oxygen, so blood rushes to active brain regions. The MRI detects these changes in blood oxygenation in real time. So when you're solving a puzzle or remembering your first kiss, we can literally watch which neural neighborhoods light up. Tesla envisioned wireless transmission of energy. We've achieved wireless observation of the brain's electrical symphony. Let me paint you a picture of something called diffusion tensor imaging. This technique maps the white matter tracts in your brain, basically the superhighways that connect different brain regions. If your brain is a city, these are the fiber optic cables carrying information at lightning speed. And guess what makes this possible? The precise control of magnetic field gradients. Multiple directions, multiple measurements, all orchestrated by the same polyphase principles Tesla developed for power distribution. Your brain's connectome looks remarkably similar to his diagrams of multi-phase electrical systems, nature and engineering speaking the same language. For neurosurgeons, this technology is basically a GPS for the brain. Before they make a single incision, they can map out every critical pathway. Speech centers, highlighted in yellow. Motor control, that's your blue highway. Memory formation, red zone, do not disturb. This precision, this ability to navigate the most complex structure in the known universe without damaging it, exists because we can generate and manipulate magnetic fields with surgical accuracy, pun absolutely intended. Looking ahead to 2026 and beyond, we're entering an era where artificial intelligence will enhance these magnetic signals beyond what physics alone can achieve. AI reconstruction algorithms can fill in gaps, reduce noise, and extract details from data that would otherwise be invisible. We're talking about ultra-high field strengths that will soon allow us to observe individual synaptic connections in living patients, not post-mortem studies, not animal models, real-time observation of the actual hardware of human thought. And here's the full circle moment. Tesla dreamed of understanding and harnessing the invisible forces that govern our reality. He wanted to illuminate the darkness both literally with electricity and figuratively with knowledge. Today, his electromagnetic legacy allows us to illuminate the last great frontier, human consciousness itself. Every time an MRI scanner hums to life, it's Tesla's rotating magnetic field spinning at the heart of the machine, probing the mysteries of the 3-pound universe inside our skulls. The man who never won a Nobel Prize, who died alone in a New York hotel room, built the foundation for technology that saves millions of lives and pushes the boundaries of neuroscience every single day. That's not just historical curiosity, that's the silent architecture of our future, one magnetic resonance pulse at a time.